all present. This side Preekal and I am a lecturer at Mihirchand Polytechnic College, Jalandhar. Today I am here to discuss with you the subject of EDC, that is electronic devices and circuits. But before starting our subject, as always I will be dealing with you related to some important information, that is about Mission Fateh, a campaign run by our worthy Chief Minister of Punjab, Captain Amrinder Singh. He says that we should wash our hands and use sanitizer, mask and obey social distancing rules so that we can come over this pandemic situation as early as possible. So let's move on to the topic of today. This is the topic of electronic devices and circuits, and the name of the topic is transformer coupled amplifier. It is a transformer coupled amplifier. As in the last lecture we have discussed about the RC coupled amplifier. So we have gone through some advantages and disadvantages of RC coupled amplifier. The advantages were related to the gain, the high gain of power and current and voltage gain. But there were some disadvantages related to the impedance matching of the circuit, right? Because of it cannot be used as the RC coupled amplifier could not be used at the last stage of a multi-stage amplifier because it is a voltage amplifier, and it is not possible for the RC coupled amplifier to match the impedance between the two stages, right? So that is why for the output stage of the multi-stage amplifier we will be utilizing a transformer coupled amplifier because of the excellent quality of transformer for the impedance matching. Now what do you mean by impedance matching? I will tell you in brief about this. Impedance matching means whenever we use a multi-stage amplifier, at that time sometimes it happens that at the input side the impedance is very high, but the circuits, the output devices that are being utilized at the output side have a low impedance, input impedance. So if a circuit in between will be used so that its input impedance should match with the circuit and its output impedance should match with the external output device that is connected as a load, that may be a speaker or anything else that you have connected over there. If there will be a difference in the impedances of the two things, that is our circuit and our load, then they could not be matched to each other and the maximum power will never get transferred from the input side to the output load. So that is why in between the two we have to connect that kind of a component or a device or a circuit so that the input circuit and the output load, they should match with each other. That means if the input circuit is having high impedance and the output load is having low impedance, then the circuit in between should be having the high input impedance and a low output impedance so that that circuit would be able to match the impedances between the two devices or the two circuits that we are using at the input as well as at the output side. So that device or that circuit in between is called as an impedance matching circuit. Here in this particular amplifier, that is the transformer coupled amplifier, we have specially designed this amplifier circuit so that there should be the excellent impedance matching, as it is the property of the transformer to match the impedances by just adjusting the turns ratio, the primary to secondary turns ratio of the transformer. So let us discuss about this circuit. It was the brief introduction about the circuit. Now let us discuss as per the rules. That is, first of all, there will be construction. In the construction of this transformer coupled amplifier, at first we are having the input AC signal, then after the capacitor Cin for passing only the desired AC signals from this input signal, then after R1 and R2 working as a potential divider biasing circuit, so that the operating point of the transistor should remain constant, and that should help the transistor to amplify the signal, right? Then after RE and CE pair, they are being used so that the output should be stable and there should not be any kind of a feedback. There should not be any kind of a negative feedback to the input side, and along with that the circuit output should remain stable. It is working as a bypass capacitor so that no voltage drop could happen over here across this emitter resistor. If there will be no voltage drop, that is this AC signal, any extra signal that will pass from this bypass capacitor to the ground, and there will be no negative feedback from this side to the input side, and it will help the circuit to amplify and to remain stable on its state. Then after, the same thing, the same circuit at the input side of this primary is being repeated, have been twinned, so that we could make the multi-stage amplifier as a two-stage transformer coupled amplifier, right? This circuit and this whole stage is the same. And in the construction, we will have this thing extra, that is the transformer with primary and secondary windings. However, the primary winding is connected to the VCC. Primary winding of both the transformers have been connected to the VCC, and the secondary winding is connected to the load. This primary transformer, this coupling transformer is used over here, and its secondary, the load for this coupling transformer is basically this second circuit. So that is why at the secondary output of this transformer, we have used this circuit as a load. That is, one connection is with the R1 and R2, that is the potential divider biasing resistors, and the second connection is with the transistor. So this circuit, the second amplifier circuit, is basically working as a load for the coupled transformer that is used in between the two amplifier stages. This is a single stage amplifier, this is a single stage amplifier, but the second single stage amplifier is used as a load for the secondary, right? And at this point, that is the output of the second stage, here the speaker is connected as a load. As I have told you earlier that the primary and the secondary of the transformer is basically using number of turns. So these different number of turns basically helps in impedance matching of this circuit, that is the high impedance, and of the speaker which is of low impedance, right? So this was all about the construction. Now let us move on to working. In the working, we will say that whenever the signal is provided from this Vin, then the capacitor, this signal will be passed in from the capacitor, and when it will be passed in from the capacitor will pass only the AC signals towards the base of the transistor, and no DC signal will be passed, as it is the property of the capacitor to stop, to block the DC signal and to pass on only the AC signals, right? Then after, R1 and R2 works as the potential divider biasing circuit, so that the operating point of the transistor should be stable, and it will be possible for the transistor to do the amplification. Now the most important part, that is this transformer, which is used as a coupling device between the two amplification stages, and because of this transformer we call this circuit as transformer coupled amplifier circuit. So in this what will happen is this transformer, the windings of the transformer, the turns of the transformer will be arranged in such a manner so that the impedance of this circuit and the impedance of this circuit should be matched to each other. If they will be matched to each other, then only the maximum signal will be transferred from this circuit as an output to this circuit as an input. Right? If we will consider the impedance matching criteria, then how it will work is, for example, RL dash is the load at the primary side. Means at the primary side, this circuit, this second amplifier circuit, this is working as a load, and at this secondary side, this speaker is working as a load, right? So this RL is basically the load resistance of the secondary side. That may be a speaker, that may be anything you have connected over here, and K square is basically called as the transformation ratio. K square is the transformation ratio, that is on which level, at which particular point the transformation is being happened. It is basically the division of secondary windings divided by the primary windings. That is the ratio of number of turns in the secondary divided by the number of turns at the primary side. The ratio of the two is basically called as K, that is the transformation ratio. So RL dash is equals to RL divided by K square, where K is Ns by Np. So here it will be Ns divided by Np. Number of turns at secondary divided by the number of turns at primary side, and the square of this. And if we have to show it in this manner, then it will become, the Np will come to the upper side and Ns will come to the lower side. As if we will solve this equation, then it will become RL divided by Ns, and the Np was in division, so that is why it will go to the upper side. So it will become like this. So it will be Np square over Ns square. So we can write it like Np by Ns whole square into RL. So this is basically the load resistance at the primary side. If we need to calculate the relationship between the resistance at the input and resistance at the output side of the transformer, then this is basically the ratio. This is basically the connection. This is basically the equation that we have to follow. That means, for example, if the value of RL, that means the load, is equals to say 100 ohms, and the number of primary to secondary turns ratio is 10:1. For example, Np is equals to 10 and Ns is equals to 1. Then what will be the value of RL dash? That is the impedance at the primary side. Then we can calculate over here that RL dash is equals to Np by Ns whole square multiplied by 100. 100 is the value of RL. In this formula we have put it, and Np and Ns is equals to 10 divided by 1. So this will become 10 square into 100, and the value of RL dash will be equal to 10 kilo ohms. It will be 10 kilo ohms. That means if we will use a transformer in between a circuit having impedance, output impedance of 10 kilo ohm and this load side impedance of 100 ohms, then this transformer will be able to match these two impedances appropriately by using the appropriate number of primary and secondary windings, or we can say the transformation ratio. The accurate transformation ratio, if it will be used, then these two impedances would be matched to each other, and there will be the maximum power transferred from the primary towards the secondary side. No doubt the this transformer coupled amplifier circuit is the best circuit for the impedance matching purpose. But when we talk about the frequency response, then it is not that much good, because if you will see the frequency response, then you can have a look that at lower frequencies, that is in the range of 50 hertz to 20 kilohertz, that means the audio range. And in the audio range, if we will see, then at low frequencies the gain is falling down. Why it is falling down is because of at low frequencies, as we all know that inductive reactance will be working over here at low frequencies as well as at high frequencies. The inductive reactance, that is, because this is L in the transformer, we use the inductance, so there will be inductive reactance. So that inductive reactance is basically directly proportional to the frequency. So at low frequencies, the inductive reactance will be low. If it will be low, then the gain will fall down at low frequencies. And whenever we talk about the high frequencies, then the inductive reactance will enhance. So that is why its internal capacitance between the two windings will show reactance to the signal flowing. So it will not give an appropriate output or gain response at high frequencies as well. And in between also, it is stable for a very low time period. It is stable for a very low time period. So that is why at audio frequencies where the RC coupled amplifier was completely stable, at that point also the transformer coupled amplifier do not have a better response, frequency response. So this kind of a frequency response basically leads to frequency distortion. It leads to frequency distortion. So this is basically a distortion. So that is why the transformer coupled amplifier cannot be used in those circuits where the high gain or a stable gain is required, and it does not provide a stable gain in any of the frequencies. But whenever there is a term of impedance matching, then this circuit is the best circuit. So in case of advantages, we will say that it is having an excellent impedance matching qualities. Then another thing is, in the advantages we will say that there is almost no power loss in this circuit, almost no power loss. But when we talk about the disadvantages, then we could say it is not having a stable gain, and it provides frequency distortion as well. So that is why it cannot be used in this audio frequency range. But in the terms of applications, we can say when we talk about the RF frequency range, radio frequency range, that is above this 20 kilohertz of range, that is related to 550 kilohertz to 1650 kilohertz. 550 to 1650 kilohertz, the radio frequency range. In that particular range, this transformer coupled amplifier could be used along with some different circuits, some tuned circuits, so that it could be used on at that frequencies, particular frequencies, for getting a good response. So it will not be used in the audio range as RC coupled amplifier was used. So all the amplifier circuits have their own advantages and disadvantages and applications depending upon the working of the circuits, right? So I will tell you in brief about the multi-stage amplifier, that whenever we work on that, how it works. Say for example, this is the input side. Here the mic is being connected at the input side. So here the voltage amplifier, that is the RC coupled amplifier, will be used maybe for 2 stages or 3 stages or more than that, depending upon the RC coupled amplifier will be used, and at the output stage this power amplifier, or you can say the transformer coupled amplifier, will be used for the impedance matching purpose. So this is all for today about the transformer coupled amplifier. I hope this is all clear to you. If there will be any doubts, then we will discuss it in the live session. Thank you.